everybody. In this video, we're going to talk about the difference between permutations and combinations. So take 3 deep breaths and let's make this math easy. All right, so when you were watching the videos about how to calculate permutations and how to calculate combinations, you probably noticed that they're very similar to each other. And the main thing that's different between the two of them is that with permutations, the order matters, versus with combinations, the order does not matter. So for example, a situation that you would use a permutation for would be if you were choosing a president and a vice president from 12 people. Because if you're choosing a president and a vice president, for your first choice, when you're choosing the president, you would have 12 different branches of your choice tree. So you would start off with 12 choices and you'd choose your president. And then after you've chosen your president, then you would choose your vice president, which means each of those branches would branch off into 11 more branches. And so you would multiply those two together to find the total number of possibilities for how you could choose a president and a vice president. With combinations, the order doesn't matter. So for example, you could choose a committee of 2 people from 12 people. So your choice tree would look the same. You would have 12 different choices for the first person in your committee, and then you would have 11 choices for the second person. However, because it doesn't matter whether you choose Abby first and then Bob, or you could choose Bob and then Abby, you need to divide by the number of duplicates, which in this case would be 2 times 1, because that's the number of ways that you could arrange 2 different people if the order doesn't matter. So the main difference is that with permutations, the order does matter. Like choosing a president is different than choosing a vice president. Versus with combinations, order does not matter, because if you choose a committee of 2 people, it doesn't really matter which one you choose first, because they're both going to be on the same committee. And there's no distinction between those 2 people. As another example of a situation that illustrates the difference between permutations and combinations, a situation where you might use a permutation is if you're creating a 3-scoop ice cream cone from 18 different flavors, because the first scoop on your ice cream cone, you would have 18 choices. And we're assuming that you're choosing unique flavors and you're not like doing 2 scoops of the same flavor. So you would say, okay, I have 18 choices for my first scoop, then I have 17 choices for my next one, and then 16 for my top scoop on the top of my ice cream cone. But with combinations, it might be something like choosing a 3-scoop ice cream sundae. Because with an ice cream sundae, it doesn't really matter which ice cream flavor you put in first, because they're all in the same bowl. Versus on an ice cream cone, it would make a difference how you stack the ice creams, because that depends on which one you're going to eat first. So to calculate the combination, I would say, well, I have 18 choices for my first scoop of ice cream, 17 for my second, 16 for my third choice. But because it's a sundae, it doesn't really matter which one I put into the bowl first. They're all just going to be in the bowl together. And so there are 3 times 2 times 1 different duplicates in the choice tree for each of these possible combinations. And so that would be the way I would calculate that. As one last example of when you could use permutations versus when to use combinations, we could look at awarding scholarships. So if you had a situation where you were awarding scholarships with different amounts to 5 out of 30 students, in this case, the order matters, because you would have 30 choices for who to give the most expensive scholarship to. Then you would have 29 choices for the next one, 28 choices for the next one, 27, and then 26 choices for who you could give the cheapest scholarship to. Versus if you were awarding scholarships that were all the same, it doesn't really matter which one you assign first, second, third, fourth, and fifth, because they're all the same money amount. And so in that case, the number of ways that you could award the scholarships would be 30 times 29 times 28 times 27 times 26. But then you would divide that by 5 times 4 times 3 times 2 times 1, because this describes how many duplicates there are in the choice tree if the order doesn't matter. And so that's how you would determine when to use permutations versus combinations. If the order matters, then you use permutations, and if the order doesn't matter, then you use combinations. So I hope that's helpful, and I hope that you guys have a good day.